I was somewhat rudely interrupted by the fact that I ran out of memory on the card and I had just written this down. But let's just complete this. And I drew a picture here that I'll draw for you again over here, this picture, because it's kind of important to see that picture being drawn. Okay, so what we said again is B row is the closest thing within C to the B vector again being our Y value vector. And that's because B row is the orthogonal projection of B onto the subspace C, onto the column space. Okay, why is that important? Well, first of all, why is it so? It's so because, as we've seen, B minus B row, by the unique decomposition, the direct sum thing and everything, B minus B row is a member of the null space of A transpose. That means that it's got to be orthogonal to the column space, or row space of A transpose, because the null space of A transpose is orthogonal for any matrix to the row space of A transpose. Okay, so, and that's the last thing I got to write, and I was probably, my arm was just barely still blocking this when I ended, when we got cut off. Okay, and why is B minus B row orthogonal to this? Because this is orthogonal to this. It's because the null space of A transpose is orthogonal to the row space of A transpose. To say this is to say, and you've done this for matrices, that any vector in the null space is orthogonal to any vector in the row space. So every vector here is orthogonal to every vector here. So in particular, this vector is orthogonal to any vector here, so that B row is the orthogonal projection, and we can visualize that by this picture, which I'll draw a little bigger over here. Okay, so if, let's say this constant, represents our row space, and our B vector, which of course is not expected to be in our row space. For real world data would almost never be in the row space. It's mathematically impossible if we have really good data. If we have perfect data, we could end up with a coincidence. Okay, what we're looking for then is, well, we come down here parallel to the null space. So this projection line is parallel to our null space until we hit the column space. Since the null space is orthogonal to the, until we hit the, since the null space is orthogonal to the row space of A transpose, or the column space, this vector that we get here is the vector that we want. This is our vector that I've called B sub row, and that's got to be equal to our AX vector. So hopefully this picture is a little bit helpful, but once we see all this, the rest is just very simple algebra that you can easily execute.